go live. I'm going live on both Facebook and YouTube, just so you know. All right. Yep. Here we go. And we are live, y'all. Welcome to Isabel Explains. Thank you, Molly, for being here on time, by the way. Today we're going to be answering a few questions. The first one is going to be, we're going to be dealing with slope, linear equations, and then after that we're going to be talking about tips and tricks on how to solve word problems, actually, more efficiently and easier. So this is something that you're probably, Molly, you're probably going to be benefiting from, even though this was sent by a ninth grader. You'll probably benefit from it. Would you mind muting yourself until it's, I hear a lot of background noise. Sorry. Thank you so much. Yeah, so if you have any questions, please obviously unmute yourself and then ask me questions. So the first thing we're going to do is, can you give me a pen, please? I forgot to get a pen. Look at that. Because I don't want to use a marker on the paper. But, thank you. So, this is the homework that you sent me, and you said, or you pointed out on the exercise that this point here is the point 40, 50, right? And what this exercise is, for those of you who are watching, basically is this guy is walking away from a booth, right? And this graph simply graphs what the distance is going to be. So this is going to be time right here, and that is in seconds, correct, Molly? Yes, I believe it's in seconds. Yeah, it's time in seconds, and this is going to be the distance from the booth, and that is in, what is it, meters or feet? Meters. Okay, so this is going to be the meters, distance from booth in meters. So they're giving her just this piece of the graph, right? So she needs to answer 4 questions. The first one is, how far away from the ticket booth was William after 1 second, right? Label the point on the graph that shows this information when it with its coordinates. And then what is the constant of proportionality, which is just a fancy name to say the slope, right? So constant of proportionality, we're just going to think of it as this slope. For the relationship between the time and the distance of the of this guy, what's his name, William, from William. And what does this tell you about William's walk? All right, so the first thing that we have to recognize is that this is a linear equation, right? And pretty much, or not pretty much, any linear equation can be written as y equals mx plus b, right? Can you see that fine, Molly? Give me a thumbs up. Yes, okay, cool. So y equals mx plus b. We know that the m is the slope, right? And we know that the b is going to be the y-intercept. Now, what does this even mean, right? Well, the slope is that constant of proportionality. Basically, when we have distance divided by time, what that is simply the speed, right? How fast is William walking away from the booth, right? That's all there is to it. And the b is going to be how far he was when he started, right? How far from the booth was he when he started at time 0, right? Like when we started recording his time, right? Because just because I don't know, we could have started recording the time when he was 20 feet away from the booth, or sorry, 20 meters away from the booth, or whatever, right? So we don't know, but we can calculate that based on what we're given. All right, so we know the point 40, 50, but we also know the point down here, right? We also know 1,000 other points in here in between, right? Because there's an infinite amount of points in between, but we're just gonna choose what's easier for us, right? We're gonna choose the simplest point. So this point right here, Molly, can you tell me what point that is? On your thing, because I know you have a copy of it.
Um, 20 and 15.
What's that?
20 and 15.
That's not 15. 15 is down here, right? Because these are actually going up by 5, right? At least mine is. Yours is a little bit different, but it's 25, right? So this is going to be the point 2025. And lucky for us, we can use that to calculate the slope of the line, right? So how do we calculate the slope of the line? Do you remember, Molly? Divide what?
Wait, what's the question again?
What is the slope of the line?
Oh.
The M.
Divide 20 and 25.
You mean like just 20 over 25?
Yeah.
Or something along those lines? You're close. You're close. So the formula for the slope, all right? So we know the easiest way to remember this, all right, is that we know that the slope is the rise over the run, right? You heard that before? Yeah? All right, so we have the rise, not rice, because you're not going to eat it, right? Over the run, right? So the rise over the run, we can do this multiple ways, right? And since we have the graph, we can use a visual aid for it. So the rise would be, like, let's suppose, the way I like to think about it, have you ever been to New York? Yes, no, yes?
No.
You've never been to New York? Okay, yeah, that's okay. It's huge. You get lost. But anyway, the cool thing about New York, though, is that all of the streets are parallel, right? Like all of them, it's like a huge grid, pretty much, right? So the way I like to think about it is like if I am at this store or whatever, and I gotta go to this store in New York, unless you're Spider-Man and you can, jump over the buildings, right? You won't be able to get there that way, okay? So the easiest way would be that you go all the way up, right? You follow this street all the way up, and then you follow this street all the way to the right, and then you get to that other location that you want to go in New York, right? I mean, you could do, a bunch of other streets in between or whatever, but for the sake of this exercise, we're just going to go all the way up and all the way there because you don't want to get lost, all right? So how far up, how many streets up, basically, do I have to go for me to go from street number 25, right, because this is my Y, from street number 25 all the way to street number 50? How many streets is that? Tick tock, tick tock, tick tock.
There is like a 10-second lapse.
Is there? Okay. You're muted. Go ahead.
25.
25, right? So it's 25. And when we're calculating the rise, right, if we're moving up, it's going to be positive. If we're moving down, it's going to be negative. Okay? Positive people go up, negative people go down. All right? I like to think about it. So now with the left and right, that doesn't work because righties and lefties, we're all the same. So that doesn't work for that. But positive is to the right and left is negative to the left. So once we get to the street number 50 here, right, I'm going to be moving from this street 20 all the way to the street 40, right? So I'm going to go from 20 to 40 right here. How far is that? How many more blocks is that? 20 more, right? It's a great workout, by the way. And that is normal in New York. So yeah, is it going to be positive or negative?
Negative.
Why negative?
Because I'm pretty sure that way would be positive and that way would be negative.
Well, it's actually the opposite. So positive is to the right, negative is to the left. Okay? So, yeah, that's what I was saying. It doesn't work for righties and lefties. It's like negative, lefties are negatives, all right? And righties are, that doesn't work that way. I'm ambidextrous, so it doesn't really matter. So yeah, so it's gonna be positive. Okay. And actually, if you want to think about it this way, is because of the number line, right? When we have a number line, if we have 0 here, can you still see that? Yeah. So all the positive numbers are to the right, all the negative numbers are to the left. Okay. So you can think of it that way. All right. Every time you move to the right, you're going positive, or you're adding, right? When you move to the left, you're subtracting. Okay. So in this case, we're moving to the right 20, right? So what we're going to do is the rise over the run, right? So the rise is 25 and the run is going to be 20, right? Another way to do that, or to do it mathematically, right, would be that literally what this is you're subtracting 50 minus 25, right? So the top is 50 minus 25, which is 25. And the top, or the run, is actually 40 minus 20, right? So one other equation we use for that, for the rise, would be, we call it like y2 minus y1 over x2 minus x1. So if we call this our second point, our first point, right, we're gonna call this 1 and we're gonna call this 2. My x1 would be, my y1 would be 50 minus 25, which is my y1. And then the x2 would be 40, the x1 would be 20, so it would be 40 minus 20. All right, and this is going to be equal to 25 over 20. So either way works. The reason I'm showing you this one is because you're not always going to have the graph, right? So if you don't have the graph and you don't have that visual aid, then it might be a little harder to figure it out. But if you know this, right, then you're set. Okay? Questions on that so far? No? You're good? All right. So what we're going to do next, let me erase this because this is technically not part of the problem. So what we're going to do is we're going to substitute that m for 25 over 20, which is actually 1.25, right? So we can think of it as 1.25, or we can think of it as 25 over 20. It's up to you, however you want to write it. Actually, 25 over 20 simplifies into 5 over 4. So if we want to think of it that way as well, that's fine. That's usually what we would do. We would normally simplify to the simplest fraction, right? So it'd be 1.25. So do you rather I leave it as a fraction or as a decimal? It's up to you. I'll give you the choice today.
A fraction.
Fraction. Yes, you're my team. I love fractions. I know, I'm a weirdo. It's fine. All right, so y is going to be equal to 5 over 4x, right, plus b. But we have no idea what b is, right? Because this line don't even go all the way to the y-intercept, so we don't know, right? But we can find out. What we can do is, what this equation represents, right, is that for every x, right, you're going, every single x coordinate that you have here for that line, right, you are going to multiply it by 5/4, and then you're going to add whatever that y-intercept is, and that's going to give you your y, right? So this x and y are, they have a relationship. This is the relationship between that x and that y, okay? So that means that I can just use any of these points, right? I can use the 20, 25, or I can use the 40, 50. Because when x is 40, the y is 50. And when x is 20, the y is 25 for this specific line. Does that make sense? Yeah? Okay. So what I'm going to do is I'm actually going to choose the smaller one because I like to deal with smaller numbers. All right. So I'm going to choose 25 is going to be equal to 5/4 times 20, which is the x, plus b. Now we only have one variable and we can solve for that. Okay? All right. And you're welcome to use a calculator here. That's completely fine. So how much is 5/4 times 20? gonna do my little dance in the meantime. Unmute yourself. What's that?
25.
25, right? So we have now that 25 is equal to 25 plus b, right? The next logical step would be, I'm running out of board here. Oh, so I can continue here. All right, so the next logical step would be to subtract 25 on both sides, right? So I have 25 equals 25 plus b. I'm gonna subtract 25 on both sides. Can you still see this okay? Yeah, all right. So this is gonna eliminate 25 here. So this is gonna become 0 plus b, right? So we don't need that. And this is gonna be 0, all right? So the b is gonna be equal to 0. Does that make sense? Awesome. All right. I love how she just gave me the thumbs up. She's like, I am muting myself for this. All right. So what we're going to do is substitute that b back here, right? So my equation now is just going to be, right, 5 fourths, y equals 5 fourths x plus 0. So we don't write it, right? Because if you're adding nothing, then there's no point in adding it. Right? You can leave it there if you want to see the visual for you, okay? But you can just leave it there, all right? So that means that my y-intercept is 0. So where is that point in the graph? Where would it be? What's that?
Bottom, like at the very, very bottom.
What is that called? I love how all of my students forget the name of it. All of them. It's awesome. It's hilarious. The origin. So it's gonna be at the origin. All right. Which means that at 0 seconds, right? William was it was 0 meters away. He was at the booth, right? At 0 seconds. Okay. Questions on that? No? Cool. All right, now the first question is, how far from ticket booth was William after 1 second? All right, how would you solve that? I'm gonna erase this part right here. Little bits.
Would you take the 20.5 and go down to the 1?
You mean like draw the line here?
Yeah.
Like,
And then
that's one way to do it. That's one way to do it, actually. You could literally just grab a ruler, right, and finish tracing the line all the way from 0 to the 25 point, right? There's only one problem with that. At least for the graph that I have, well, actually, this one would show, I think. No, it doesn't. Because the only problem that would have is that depending on the, what is it called? The division, I guess, or the, it's not called the range. I forget, I'm blanking out. But it's okay. Depending how the grid is set up, right, you may not have an accurate number to compare it to. Okay, like for example, this one is going up by 5s, right? So at 1 second, when I hit 1 second here, it might fall like right in between the 0 and the 5, and I don't know exactly what point would be. Okay, so that is the one disadvantage of graphs, because sometimes you just don't know, right? Like it's kind of like somewhere in the middle of the point, and you're like, I don't know, right? So the more accurate way to do it would be to simply, we know that the x's are the time, right? And the y represent the distance, right? So we can just substitute the 1 second for the time, right? So, does that make sense?
no.
Okay, so remember that, so let me rephrase this. So we said that when x is 20, y is 25. Right? So what that means is that at 20 seconds, he was 25 meters away from the booth. Does that make sense? So at 1 second, how far is he going to be away from the booth? That is the question, right? So when x is 1, what is the y? Does that make sense? Because x is the time, y is the distance. So when the second is 1, there you go. So when the second is 1, what is the distance? What is the y? Okay. So I like to, personally, when I have stuff like this, I don't like to write it as x and y. I actually like to write it as t and d here, right? Because then I know that this is time and this is distance, right? It's easier to see it that way. All right. So when the time is 1, what is the distance, right? What is the d? Okay. So all I'm going to do, so I'm going to change this here too. All right. So this is going to be xt and y is the time. So I'm going to make this 1 second. Okay. And since this is in seconds, right, which we have to make sure that the units match, right? Because if it would have said how far was he after 1 minute, then you can't use this graph. You would have to change it to 60 seconds. Okay. So you always make sure that you know which units you're dealing with. All right. So 1 second. So the distance is going to be 5/4 times 1, right? Because it's 1 second plus 0. So we just don't write anything. Does that make sense? All right, cool. So what is the distance? The distance is going to be equal to what? 5/4, right? Or 1.25 meters. Okay, so 5/4 of a meter or 1.25 meters. That's how far he was after 1 second. Because he was walking at 1.25 meters per second. Does that make sense? Cool. Awesome. All right. So the second question is, so we know this is going to be 1.25 meters. The second question is, label the point on the graph that shows this information with its coordinates, right? And that would be what you would have to do, right? So you would have to trace it here. This line is gonna suck. So let me just give you the warning right now. I should have had a ruler with me. Assistant, where is my ruler? It's okay, it's too late, never mind. I love you all the same. All right, so what we would do is find the 1 right here, right? I know this is super tiny. We would find the 1 and, just plug in that point, whatever that is. In your graph, even, it's not going to look perfect. Like, even if you find the 1, which I don't think you will exactly on your graph, you might, actually. I'm trying to remember what it looked like originally. But the point is not going to fall. Thank you. The point is not going to fall exactly on another dot because I think yours is going up by 10s or by 5s or something like that. So it's just going to show somewhere in there. Okay. So don't worry too much about that. Questions on that? No? You good? All right. So we got that. And then what is a constant of proportionality? Dun, 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 dun. You're muted.
Wait, so answer the full question or just that?
Well, it's the same. What is the constant of proportionality for the relationship between time and distance? But it's okay. What is the constant of proportionality? What? Say that with a little more confidence. Come on, you got this.
25.
25 or 1.25?
25.
25. Why 25? Is he going 25 meters per second? Is that how fast he's going? Because if that's how fast he's going, that man is fast. He's leaping like a gazelle. All right? No, that's a slope. Right? That's why I wrote it here. The constant of proportionality is just the slope of the graph. Right? So what is the slope of the graph? 1.25. That's the constant of proportionality between for the relationship between the time and the distance that William is walking. Does that make sense? Yeah. Yeah, constant of proportionality, when it comes to time and distance, it's simply speed, right? How fast is he going? That's all that means, right? If here the other word would be like slope, right? And then I was gonna say something else about that, and I just blanked out. Oh, so the slope, the way I like to think about it, just super quick side note, is that I like to think about it as when you're on a treadmill. You've been on a treadmill before, right? Hopefully, maybe no. You've never been on a treadmill. Cool. So you never like busted your face on it. That's fun to see other people. No, I'm kidding. So when there is a feature on the treadmill, usually, right, that you can adjust the inclination of the treadmill, right? So you can go uphill and stuff like that, right? And the higher the number, the higher the inclination, right? The more steep it's going to be, okay? It's the exact same thing with the slope. That's literally what the slope means. The slope is the inclination of that graph. How steep is that graph, right? The larger the number, even if it's like larger negative or larger positive, right? The steeper is going to be the graph, okay? The steeper is going to be the line. So if we have a line like this, for example, right? Can you see next to it? Yeah. So if this is our graph, right? If you have a line like this, what is the slope of that line right here? Five, four, three, two, one. Give me your best answer. You're muted. Was that?
I'm not sure.
All right. So a lot of my students say it's 0, right? It's not 0. It's undefined. Okay? It's an undefined slope because unless you're Spider-Man, you're not going to be able to walk on it. All right? So if you can't walk on it, it's an undefined slope. All right? The treadmill is just going to throw you off. All right? Okay. So it's undefined. The treadmill will never go that high. Okay? Now, what would be the inclination of this graph, of this line? It's supposed to be flat, by the way. I know it's terrible drawing, but it's supposed to be flat. It's a flat line. What is it? 0, because it has no inclination, right? It's a flat surface. Okay? You can walk fine with no inclination. All right? When you get on the treadmill, that is usually the default, right? The 0 inclination. All right? Awesome. Questions on what we've done so far? No?
Not right now.
All right. So the last one is, what does this tell you about William's walk? What can you tell me about William's walk?
That he walked.
You got this. What do you know about his walk? How fast is he going?
1.25 seconds.
Meters per second. Right? He's going at 1.25 meters per second. That's how fast he's walking. Okay? Does that make sense?
Yeah.
All right. Whoops. Wait. Stuff that happens on live. Questions on that? No? All right. Cool. So, any other questions? No? All right. So, we're going to move on then super quick to the other material that I had prepared for today. And you are welcome to stay because I think this is actually going to be very beneficial for you as well. It is basically, how do you like word problems?
They're okay.
They're okay. Good. You're one of my few students, or only student, to ever say that. I'm like, I hate word problems. But that's all right.
I mean, they're not that bad. I just take out like the most important information and use that.
Yes. Okay, so you should teach this lesson right now. All right. So, so Molly, on to you. No, I'm kidding. Okay, so like Molly said, right, the most important thing when you're doing a word problem is literally just find what is important about it, what is relevant about the problem, right? Because sometimes they're gonna tell you things like, well, in Yellowstone, the highest mountain is this much, and then they're talking about the depth of their what are they called, glaciers, whatever, you know what I'm saying, right? And then it has nothing to do with the height of the mountain, right? Like it's completely irrelevant. All right. So you have to, the first thing that you have to find out is what is important, what is relevant about those word problems, right? The quick tricks I have for that one, actually, let me pull it up real quick because I have it here on whenever my computer decides to load. Where are you at? So one other trick that I use a lot is that every time you see the word is, all right, that is an equal sign. Literally anywhere you see is, bam, that's an equal sign. Okay? Every time you see something like it's greater than or is less than something, what you gotta do is put that less than or plus sign, right? So actually, we're gonna see that in here, but what we're gonna do is put it after that. Okay, let me see what other tricks did I write down that I forgot to print out. Look at me, so irresponsible. All right, so all right, so come on. All right, and also know that for every single word problem is gonna have at least one unknown variable, right? And in order for you to solve it, right, in order for you to solve it to have like an actual numerical value, you need to have at least one equation per value, per variable, okay? So if you have only one variable that you're solving for, then you only need one equation, right? But if you have two variables that you're solving for, you need two equations. Otherwise, you're just gonna have to leave it expressed, as the variables, because you don't have enough information to find out what the value of variable A or variable B is. All right, does that make sense, Molly? Yeah, cool. All right, so anytime you see anything like twice as much or times that, right? Something more times or whatever. What is it called? Like times as much. Sorry. So times as much or anything like that. That is just multiplication, right? So you're just gonna throw that number in front of that variable, right? So it's like 3 times as much. Well, that would be like 3x or whatever the variable that you have chosen is. And the word and usually means that there is a second equation coming up. Okay, so and we're gonna see that in one of the examples. So the first example is the sum, right here. The sum of two numbers is 84 and one of them is 12 more than the other. All right, so the sum of two numbers, that is telling us right away that we have two variables, right? We have two unknown numbers. So we have two variables. So I'm gonna call number A and number B, right? I don't know what they are, but I know that the sum of those two numbers is equal to 84, right? So A plus B, the sum of those two numbers is 84, okay? And meaning another equation, right? One of them is 12 more than the other. Now, they're not telling us on the first part which one is greater than the other, right? I don't know. So I'm just going to choose either of the two, okay? So I'm going to say one of them meaning A or whatever, it doesn't matter, is equal 12 more than the other. So this is what I meant where you're going to write the plus sign after, right? So it's going to be more than 12 more than B. Okay? Does that make sense? Yeah, cool. All right, so how do I solve this? Well, very easy. What I'm going to do is like if A is equal to B plus 12 and A plus B is equal to 84, but I know that A is B plus 12, I can substitute that A for B plus 12 because they're telling me that that's what A is. A is B plus 12. So I'm just gonna substitute this A and rewrite it as B plus 12. So now I have, if I move down here, this is gonna be B plus 12 plus B is gonna be equal to 84. All right? Does that make sense so far? Cool. So B plus B, right? Every time I'm adding or subtracting, okay, I like to think of them as boxes. All right, so it's like I have one box plus another box. Now, how many boxes do I have? I have 2 boxes, right? So it's 2B. All right, so 2B plus 12 is going to be equal to 84. Okay, so the next step, the next logical step would be to subtract 12 on both sides, right? Because the whole point is we want to leave B alone because we want to solve for B. So we're going to subtract 12 on both sides. All right, so this is going to be 84 minus 12, which is 72. Okay, so 2B is going to be equal to 72. Can you see that? Is it a little too low? It's too low, isn't it? 2B equals 72. All right. And then, so since 2B is equal to 72, what do I do next?
Divide them.
By?
Wait, yeah, divide 2 on both sides.
Yes. So we divide 2 on both sides. And how do we know that? Because the 2 is multiplying the B, right? So you always want to do what's opposite to what the 2 is doing to that B, right? 2 is multiplying B, you want to divide by 2, which is the opposite of that. So 72 divided by 2? That's okay. 36. B is equal to 36. Okay, so we know what one of the numbers is, right? We have 2 numbers that we have to figure out. So what would be the second number? Well, I can do it 2 ways. I can either substitute the B up here, right, and say A plus 36 equals 84. Or I could just use this one. I already know that A is isolated, right? And it says that A is equal to 36 plus 12, right? So that B, which is 36, so A is going to be equal to 36 plus 12. So A is going to be equal to 48. And that is my 2 numbers. Questions on that? No? Cool. All right, moving on to the second exercise. I need a better eraser. I really do. All right. This is example number 2. All right, so example number 2 says the sum of 2 consecutive numbers is 37. Right? Now, this one is one that trips up a lot of students, right? Because we're like 2 consecutive numbers. I don't know. Like, I need to know what number it is. You don't. Because you know that every single number that goes after another number is that number plus 1, right? I don't know if that made any sense. But for example, 5 is 4 plus 1, right? 6 is 5 plus 1. Right? 7 is 6 plus 1, and so on and so forth. Every single number is 1 more than the previous number, right? Consecutively. right? So consecutive numbers. So I know that the sum of these two consecutive numbers is going to be 37. So I know that the first number, I'm just going to call it A, right? And the second number is going to have to be A plus 1, right? Because it's consecutive, right? You could write it as A minus 1, being like, well, it'd be the number before. It doesn't matter, as long as you keep track of what you're doing. But I'd rather just use positives instead of negatives. They get confusing, all right? So I know then that the sum of these two, meaning A plus A plus 1, is going to be equal to 37. Okay? This is first number. This is the second number. Okay? So, A plus A, 2A. Right? So 2A plus 1 is going to be equal to 37. I subtract 1 on both sides, which is going to be 2A is equal to 36. I guess 36 is the number of the day. And then we're going to divide by 2 on both sides. Okay, so A is how much? I'm just doing that at this point to torture you. She's laughing, and you guys can't hear her, but she's laughing. So A is going to be equal to?
1.
No, we're dividing by 2. 36 divided by 2. How much is A?
Oh. Wait, 36 divided by 2 or 2 divided by 2?
Well, 2 divided by 2 is A. 2A divided by 2 is A. And then we're doing 36 divided by 2. So 36 divided by 2 is?
16.
Close. 18. 18. Okay? So we know then that the first number is going to be 18, right? That's my first number. And my second number is going to be? No. We have two consecutive numbers. The two consecutive numbers add up to 27. To 37, sorry. The first one is A. The second one is A plus 1. So if this first one is 18, what's that?
19.
19. 19 is the second number, right? So, does that make sense? Cool. Questions on that? No? All right. Let's do the third one real quick. Let me try to get rid of this. Hope I don't break this thing. Here we go. All right. So, third one. All right, here we go. So the sum of two numbers is 84, and one of them is 12 more than the other. Okay? So, sum of two numbers is 84. We know we're going to have two different numbers. I'm just going to call them A and B. Okay? The sum of those two numbers is 84. So how would I write that?
A plus B equals 84.
A plus B equals 84. Bam. Right? And it says that one of them is 12 more than the other. Right? So what are the two? Did we not do this? Wasn't this the first exercise? I missed out the second one. We just did this. We just did this one. I made a boo-boo. Well, anyway, it's okay because we already did it, so you know how to do it. So A plus B is equal to 84, and then how do we how would we do the second part? One of them is 12 more than the other?
You do A plus 12.
I wrote B. Plus 12?
You draw a square with that, and then you move it to like the A over there, and then you do.
Wait, hang on. I need an equation here. Right, I need it to be equal to something. What is it equal to? What is A plus 12?
Equals.
One of them is 12 more than the other. equals B. Yeah. Right? So in the previous time, we did it with A is B plus 12, right? But it doesn't really matter. You can choose whichever you want. Okay? What you have to be careful with is when they actually state which one is larger than the other. Okay? That's when you have to get it like right. Right? But in this case, it doesn't really matter. One of them is 12 more than the other. This one is going to be 12 more than this one. Right? Because whatever A is, B is going to be 12 more than that. Okay? Does that make sense? All right. So in this case, what I'm going to do then is solve for A, right? So I'm going to substitute this B for A plus 12, right? This B is going to be my A plus 12. So I'm going to end up with A plus 12 is going to be equal to 84. Okay? And then we solve, so that'll be 2A plus 12 equals 84. Subtract 12 on both sides. This is going to be 72. 2A equals 72. A is equal to, you can't see it. A is equal to 36. Which is pretty much what we established first, right? We had that B was equal to 36 in the previous time, right? But it doesn't really matter. Just one of them is 36. And the other one is going to be what? B now is going to be what?
48.
48, because it's 36 plus 12, right? So it's going to be 48. Awesome. Questions on that? No? All right, I hope exercise number 4 is not the same as number 2. Let me see. No, okay, good. I was like, oh my gosh. I guess, I don't know. I made a mistake copying and pasting, I guess. It happens. I'm human. All right, last one. Now I want you, so you can go ahead and unmute yourself. I want you to tell me what to do about this one. Okay, I want you to follow those guidelines. Okay, so is an equal sign, right? Remember that minus than or less than or plus than or greater than, right? You're gonna write the plus sign afterwards. All right, and the and means it's a different equation. Okay, so go for it. One number is 10 more than another. What do I do?
You would do A.
Mm-hmm.
And then plus 10.
Mm-hmm.
And then the other part, the sum of twice smaller plus.
But we're not there yet. We're not there yet. One number is 10 more than another number. We have 2 numbers. We are only dealing with A here. Where's my other number? I'm going to do the dance in the meantime. One number is 10 more than the other number.
So, erase the 10 and put the B.
Say that again?
And for, instead of the 10, have a B.
Okay.
So A plus B.
A plus B what?
Use one of the numbers and do plus 10.
Okay, so A plus 10 is equal to? We have to have an equation. Something has to be equal to something, because otherwise we can't solve it. Right? So let's follow the guidelines. Let's stop right there and let's follow the guidelines real quick. Right? So I mentioned, where's my pen? I mentioned that every time you see the word is, this is an equal sign. Right there, right off the bat. One number, I'm going to call this one number A. All right? It's 10 more than another number. I'm going to call this number B. Okay? So A is this number plus 10. Because this number, one number, is going to be 10 more than B, than the second number. Does that make sense?
So A equals 10?
Plus B. Plus B. Right? A is 10 more than the other number. Right? So B plus 10. Because no matter what this number is going to be 10 more than that. Right? So if this was like 20, well, then A is 30. Because 20 plus 10 is 30. Right? Or whatever the number is. Okay? So A equals is 10 more, right? So we always write whatever that more than what? More than B. More than that second number. Okay? Cool. The sum of twice the smaller number plus 3 times the larger number is 55. I know that's intimidating, but let's break it apart. We say the sum of twice the number, we know it's going to be 2 times whatever that number is. I don't know what the number is, but it's the smaller number. Which one of these two is smaller, A or B?
We don't know yet.
Yeah, we do. Because it doesn't matter what this number is. B is smaller. Because it doesn't matter what B is. A is always going to be 10 more than B. Right? So twice the smaller number, right? The smaller, so which is B. We have determined that. All right? Plus, that's literally just a plus sign, right? 3 times the larger number. So it's going to be 3A. Because we know the larger number is A. Right? So that's literally how we write it. So because we know it doesn't have an and, but it's a different sentence, right? So we can assume it's a different equation. The sum of twice the smaller number. So the sum of twice the smaller number plus, right, 3 times the larger number, which is A, is, right, is an equal sign, is 55. Does that make sense? Yeah? All right. Now, I mentioned that if you have 2 variables, you have to have 2 equations. We have 2 variables, we have 2 equations. So now we can solve for it. Okay? So what I would do is, this is already, like simplified, right, by A. It's like I already know what A is. So I'm just going to go ahead and substitute whatever A is into this one. Right? I don't have to do a lot of calculations or none of that. So I'm just going to rewrite this into this A, because that's what A is. We know that A is B plus 10, sorry. So we know that 2B plus 3 times B plus 10 is going to be equal to 55. Okay? What do we do first? PEMDAS. What do we do first?
You do 3 times B and 3 times 10.
Hallelujah! Dude, you're literally the first student who doesn't say it's 3B plus 10. I'm like, it's not 3B plus 10, it's 3B plus 30. Don't forget about the other guy. All right, so 2B plus 3B plus 30, right? It's 3 times 10. That's going to be equal to 55. Okay? 2B plus 3B. 2 boxes plus 3 more boxes. Molly?
That would be 5B.
5 boxes, right? 5B. Or whatever that is. Right? And that's going to be plus 30 is going to be equal to 55. All right? So what's the next logical step?
Divide both sides by 5.
Not yet. Because if I divide, I mean, I could, because 30 is also a multiple of 5. We could do that. But I'd rather just get rid of the 30 first. Okay? Does that make sense? Yes, no, yes.
So subtract.
Subtract what?
By 5.
No, subtract 30.
5. Well, 30 minus 5. And
then... No. Subtract 30 on both sides. So I'll subtract 30 here and subtract 30 here. Right? I don't think we can see my finger. Sorry. It's too low. So, sorry. I have 5b. Can you see that? Yeah, 5b plus 30 equals 55. Is that better? Oh, it's like taking off over there, apparently. But that's okay.
A little bit, but it's fine.
All right. So 5b plus 30 is equal to 55. So the easiest thing would be to just subtract 30 first. Right? So if I subtract 30 here, subtract 30 here, that's going to leave me with 5b, because this is 0, right? Is equal to 55 minus 30, which is?
25.
25, yes.
Yeah.
25. So what do I do now?
And now you divide both sides by 5.
Now I divide by 5. Okay, so that would have been b equals 25 over 5?
5.
5, because it's a perfect square. So b is equal to 5. Now, we found b, now we gotta find a, right? So a is gonna be what?
A equals 3b.
b plus 10. b plus 10.
3 plus 10. Oh, so then 15.
15. Right? So a is equal to b plus 10. You could substitute it here, but it's going to take you forever to solve it. So don't do that. Just use this one. Right? So a is going to be 5 plus 10, which is equal to 15. So a is equal to 15. All right? Questions on that? No? All right. Had you divided by 30 first, by the way, or I should say 30 in the first place, right? You would have ended up with 5b. So it was 5b plus 30 equals 55, right? Can you see that? Yeah. So let me do this like a little tiny box here. Had you done that, it's not a downside because in this case it would have actually worked. But the only problem with that would have been that you would have had to divide also the 30 by 5. Right? So it would have been 5b over 5 plus 30 over 5 equals, equals 55 over 5. Okay? Because this is a sum. When you have a sum, you have to divide both of them. Right? So we would have b plus 6, right, equals 11, because 55 over 5 is 11. Right? And then you would have subtracted 6 on both sides, and you would have been left with b equals 5. So you would have reached the same answer. Okay? That is not a problem. You would have reached the same answer anyway. I just want to make sure that you're careful and mindful about that if you divide by 5 first, you also have to divide by 5 the other number. And in this case, it would have worked because 30 is a multiple of 5. But if it wasn't, then you would have been stuck with a fraction, right? Or a decimal point. Or something like that. Okay, so that's why it's so much easier to just subtract the number to the other side first and then divide. Okay? Cool. Any other questions? It's been an hour, y'all. Woo! This was supposed to be like 30 minutes. But that's all right. Any other questions?
I don't think there's any more. I think that's it.
All right. Cool beans. So was that helpful? The whole like is the equal sign and the and is a different equation, stuff like that. Cool. All right. Awesome. Yeah. So yeah, thank you so much for coming. I gotta do the raffle real quick. So it was you and another girl that filled up. I didn't make this, my husband did. So I have no idea who is who. So I can't cheat and be like, oh, Molly. I don't know who's gonna come out. But the other girl's name was Annika from Tennessee. She wasn't able to join us today. I'm not sure what happened. I'll probably follow up with her. But let's see. And they're all folded, by the way. I can't see them. Look, I can't see. So what we did was, so it's only 2 numbers. So I hope this is what he did. Because, husbands don't do one thing and they do whatever they want. Now he's looking at me all mean.
You just told me to write their names.
And I said 3 of each.
Yes, there's 3 of each.
There's 3 of each. Okay, good. I love you. I just love messing with him. Anyway, so I did 3 of your name and 3 of Annika's name. I hope I'm saying her name right. I don't know. Was the other person in the raffle. So we're gonna see. So he wrote them, so I don't know who is who. Let's see who won the 30-minute free 101 lesson with me. And it was actually Annika. So here you go. Like, you can't see that because it's blurry, but that's okay. So Annika won the 30-minute free lesson, so I'll contact her if she happens to not claim her prize, and I'll just give it to you, I guess. But you just had a whole hour with me. So I hope this was helpful, you guys. For everybody else on the live as well. As Molly, thank you so much for being here, staying here for a whole hour. And yeah, I will see you guys on my next live. I have another live next Saturday as well. I know a lot of people would have already been done with school. So I can do, it's for science or math. I can either do anything that you guys want to catch up on after, like, hey, this is what I did in my exam, last exam or whatever, that I didn't understand or anything like that, to make sure that you start the next semester strong. Because math, especially math, but also science, if you miss a gap, right, of something that you didn't fully understand, it's gonna pile up on top of it, right? And then everything that gets more advanced, then it's just gonna be a disaster. But yeah, I'm here for you guys. This is why I made this channel, to provide some sort of free tutoring for you guys, and I hope to see you next Saturday. Bye. All right, let me disconnect.